So when you fire up your Microsoft Teams, you should end up on a page like this with some tiles on it, right?
Yeah.
Everybody should have a tile that says 8-PC. The PC stands for pre-calculus. Oh, I'm sorry, not 8. We're in 4th. 4-PC. It was a day ahead. 4-PC, yes. You have 8. Okay.
Wait, what's the code?
Should be no code needed. I will walk through how to do this in a second. I'm just getting us all to one spot. Lucas, I just added you in. So you should be in now. When we get to loading the notebook, yours is going to take forever and a day because you just got added this second. It takes a million years for the stuff to sync through. Maybe by the end of class, it'll have come through for you. Just giving you the heads up. Okay, you guys all see the 8PC, right? Or I'm sorry, 4, Mr. Kulik, 4. It's Monday, not Monday. It's the first day. It's an A day. 4PC. Click it. So click that tile that says 4PC. Okay. So you should be at a page that looks like this now. On the navigation panel on the left, you should see something that says Class Notebook. Click that. You notice as you click it on the right panel, the OneNote image is kind of starting to populate in, right?
Yeah.
Once that's come through, you're going to be looking for the drop down here on the right on that top navigation panel. Now mine says editing because I'm the person that made the notebook. Yours will probably say viewing. From that drop down, you want to pick open in desktop. Once you do that, it'll automatically open your OneNote and load in the new notebook, and everything should be done. Lucas, you'll probably have to wait to do that last step, but it's, not much. Yes.
My line says open in browser.
Same. That's strange. Okay. Let me think, I'm going to just walk over.
Yeah.
Looks like it's there. Tap the drop down. Yes, you're good. Congratulations. You're welcome. It's off to a good start, right? Yes. Leave your tablet here, though. It seemed like it really wanted to come with you.
I know.
Let's. Yeah.
Oh wait, it's not there. Oh wait, you just use it anyway.
Okay. Where's my other missing person? Uh-huh. I know. I know, it's exciting, isn't it? Who am I missing? Oh, maybe it's one of the new people? Says I have 20. I have 18 written down. One person's already marked absent. Who's my missing extra person? It's got to be one of the new people that I don't know their names yet. All right, new people to the class. That would be Emma Shorter. That's you, okay. I'll write that down. Or Rocco Wisniewski, that's you, okay. Sebastian Asmar, yeah, okay. Well, who the heck is my missing person then? Nick Lushai. I gotta figure this out. Sebastian, Gianna's here. Gabby's here. Addie's here. Hannah's here. Mary's in the bathroom. Lucas is here. Nina's here. Lily's here. Grace is here. Dan's here. Isaac's here. Nick is absent but marked absent. Brady's here. Kara's here. Emma's here. Adriana's here. Charlie's here. Lauren's here. Rocco's here. Oh, I'm so dumb. Okay. It was fine. Got it. All right. So, looking at your OneNote, should have something on your drop-down that says for PC. If it didn't open automatically, if you go to more notebooks, it'll be there in that list. Okay? If it didn't open automatically, it should have, but occasionally it doesn't. I don't know why sometimes it doesn't, but if it doesn't, you can pull it from there. If you're in this class first semester, you can close your first semester notebook. So to do that, you just like right click on the notebook and hit close. Everything in there is still there. You just gets it out of the way of like trying to sync and update, and it just gets it out of the way for you. You can always reopen it and go back in it, but it just gets it out of your way for now. You can do that to any notebooks you no longer need for any other classes, just FYI. All right. So when I provide you stuff for your notebook, oops, the right spot, will be in the content library, except I haven't ported everything over yet, apparently. Oh boy. Oh boy, is he, Mr. Kulik. Well, let me do that real quick. Okay, so I'm moving everything over right now, so it'll be a minute. I'm just going to talk while this is going on. I'd show you the syllabus, but it's in the process of like moving over, so it's not going to let me do anything. Those of you that are new, way the class works. Homework assignments come in like weekly problem sets. So we'll assign problems periodically during the week. That homework is due, turned into your OneNote by Sunday at midnight. You have a week of grace if there's a technology issue or a late issue with the homework. So as long as that's in by before the following Sunday, there's no late marking on that homework. If you are submitting something late, though, you do need to email me a notification that be like, hey, I turned in the assignment, blah, 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 late, it's in my OneNote now, can you please check it, or something like that. Because I don't get any notifications from OneNote that you did anything, right? So I can't tell if you don't let me know. typically Monday morning, I start checking in homeworks. If you get checked in something as missing or incomplete, and you're like, hey, I did that, it looks like it's all there on my end, you probably just need to sync your notebook. So to sync your notebook, you just move your mouse button onto like the notebook name, and you hit sync this notebook or sync status. So I like to do sync status because it gives me the bars. You just hit like sync all, and then it shows you progress. And like once those are all green, everything should be synced through, and you can close your OneNote out and everything should be synced. Then you'd send me an email, be like, hey, I don't think I synced my notebook. I just did it. Can you recheck my homework? And I'll usually give you a thumbs up back when I do it. Does that feel okay? So the homework you can write by hand on a sheet of paper and like take a picture and drop that picture into the OneNote, or you can write directly in the OneNote. Either is fine. Doesn't matter to me. Whatever's easier for you, Lauren. Oh, they're graded in it. I just hide the grade. So you have to look at your report card to see the letter grade. I think today or tomorrow or something. I'm not sure. Grades were due yesterday morning at 8 a.m. for us. So.
Wait, how do you sync your notebook again?
You right click on the notebook name and you pick either sync this single notebook now. I like to do sync status and sync all my notebooks in one shot because I get the progress bars.
Okay. Is homework graded for completion or accuracy?
Completion. Yeah. Accuracy is nice, but it's homework. You're gonna make mistakes. That's okay. So far so good. At least one time per chapter, we'll have a surprise homework quiz. Usually I'll give you some idea that like, hey, this is coming. The homework quiz is just based on recent homeworks. They're typically short, like in the 15 to 20 minute range in terms of time, like 1, 2, 3, 4 questions. I grade those on kind of a loose 10-point scale, right? How loose is the 10-point scale? Pretty loose, right? Like if you show anything that resembles a correct idea, your minimum is like a 7. Like if you get something like completely right, it's probably like an 8. If you get multiple things completely right, it's probably like a 9. If everything is mostly right, maybe up to a couple of minor mistakes, it's probably a 10. Pretty easy grading scale. Very hard to do poor on them if you've done any of the homework and have any clue what's going on. It's just an opportunity for me to check in to see like who's been doing stuff and who hasn't, and me to get you guys a little bit of feedback as to like, oh yeah, you're on the right track with this, but like this part's wrong and you didn't do this right, or you didn't, or this was right, but you just wrote down the wrong number or something, you know, like gives me a chance to give you some feedback before the test or whatever. There'll be a test at the end of kind of each chapter. Those tests are graded right or wrong. Partial credit is available for most questions. That partial credit will be determined or granted based on demonstration of understanding. So like the more work shown, the better. This is not at all what I want. Okay, that's fine. I'll just make a new one. I thought this was blank. All right. New people, questions about any of that stuff? Okay. The syllabus is, okay, so on the My Notre Dame, we click on our class page. The syllabus is there apparently 3 times. Oh, I have some mess to clean up here. I record the lectures and I'll post the links to the videos here. I have some cleanup to do. I think I merged the wrong class from first semester, so I have some cleanup to do. I'll take care of that at some point. Everybody okay? So the weekly agenda and all that jazz. All right. Let's get started then, yeah? So in the OneNote, if you look at the OneNote, I have like a page attached called Lessons, so that has like the notes that I'm kind of working from. Or the lesson pages that I'm kind of working from. There's a page that says problems, so like if I assign 1 through 4, this is the 1 through 4 I'm talking about. There's a page with the odd solutions. It has like the answers to the odd problems. There's the review pack, so this will include the format of the what the test will look like. There may be additions or deletions from that. These are old and then a key for that. It's okay? Yeah.
Is all of the stuff from our old OneNote and this OneNote?
So all of my notes and stuff should have ported over, or at least a version of my old notes and stuff have ported over. I may end up like deleting and then redoing this because I think I just grabbed the wrong stack of stuff here a second ago, but it'll by next class it'll all be sorted out because I thought I did this yesterday and apparently this was the class I didn't do it for. So we'll egg on my proverbial face, but we will survive. All right, let's begin then, yes? So we have one stray trigonometry topic from first semester that we still need to kind of complete. After that, it'll be done with sine, cosine, and tangents for the year. You won't see those again outside of this topic here that we're going to be doing to start. From there on, things will resemble more closely topics from like Algebra 2. So let's go, right? Let's go. All right. So to start, you guys should remember the direction from geometry. Solve the triangle. What does this direction mean when you're asked to solve the triangle? Rocco. Yeah, so we need to find all the sides and all the angles. Okay. How much information are you going to be given to do that? What's the minimum amount of information you're going to need to be able to do this? We did this in geometry to some extent, right? Hoping to remember. So you need 3 pieces of information at minimum. 3 pieces of information. So for example, 1 angle and 2 sides. Yeah. The only exception, what 3 pieces of information aren't going to get you anywhere? Think hard. 2 angles and a side is great. That's wonderful, right?
3 angles.
Yes! Yeah. How am I going to figure out the side lengths if all I have are 3 angles, right? I could have a little itty bitty triangle or a gigantic huge one. Both have the exact same 3 angle sides. or three angles, but the sides could be vastly different, right? What are those two triangles that are like different sizes but have all the same angles? They're proportional, which makes them similar triangles, right? That have different proportions but have the exact same shape. Does that make sense? Remember that from geometry? Okay, so that's no dice. Three angles isn't going to get you anywhere. You can't find the side lengths from that. But if you're given three of anything else, two sides an angle, three sides, two angles and a side, one angle, two sides, all of that's enough to solve your triangle. Everybody's okay? Now, the easiest situation is when one of those angles is 90 degrees. What do I do if one of the angles is 90 degrees? We can just do SOHCAHTOA. Okay, so if you're given an angle that's 90 degrees, just SOHCAHTOAing that stuff. Let's do it a couple of examples to remind you how that goes. Sound good? Again, we did this a little bit at the start of the semester in regular pre-calculus before we started trigonometry. That was kind of our jumping off point. And you did this probably a bunch in geometry, but that was a little while ago. So let's okay, so let's say we want to solve this triangle ABC. So we're told angle A is 36 degrees. We're told angle B is 90 degrees. And we're told that side AB is 5. We still need to find BC, AC, and angle C. So far, so good? Which one of those is the easiest one to find? Nina.
C.
Angle C, yeah, why? What do you have to do to find it?
You just add 36 and 90 and then subtract by 1.
Great. So that gives us 54. Did we have to do that as our first step? No, man, but it's so easy. It's like getting like your teeth sunk into it. It's a nice place to start because it's a really easy step. Everybody good? Okay. Now, let's say we want to solve, we're going to pick a side to solve for next. Let's solve for BC next. To solve for BC, I'd want to start by picking an angle to use. What angle can I not use? The 90-degree angle. You cannot use 90 degrees. Does it matter which I use, the 36 or the 54, though? No, man. Which one's safer? The 36. Why is 36 safer than 54? It was given to me. I didn't have to find it myself, right? Is there a non-zero possibility that I made an arithmetic error and screwed up the 54? Yeah, it's possible. I didn't, right? Like, I'm confident I didn't. But let's say we're using the 36 because it's safer because it was given to us. Does it matter, though? No. All right. Relative to that 36-degree angle, angle A, is side BC opposite, adjacent, or hypotenuse? Opposite is correct. Does everybody agree with that? Can we see why that's opposite? Does anybody not understand? Really important that you're able to pick out opposite and adjacent and hypotenuse given an angle. Okay, everybody's good? Now the side we know, relative to angle A, that would be side AB, where the 5 is. Is that opposite, adjacent, or hypotenuse? Adjacent. Gonna ask again, everybody's okay? Which trig function should I be using if I have opposite and adjacent? Tangent. Everybody so far so good. So I'm going to write tan of angle 36 is equal to opposite, which is BC, over adjacent, which is 5. Everybody's okay with how I got opposite over adjacent? What I use to do that? SOHCAHTOA, right? You can all spell it. It's a good one to remember. All right. So now I've written my equation. All I need to do is solve for BC. What do I need to do to both sides of this equation to get the BC by itself? Multiply by 5. And at this point, it is now calculator time. Where did my calculator go to? Here you are. Okay. I'm about to use sine, cosine, and tangent in my calculator. What's the first thing I should do before I start typing things in?
Degree mode.
Make sure I'm in the correct mode. I should be in degree mode. To check the mode of your calculator, we press the mode button. It is that 4th option. So I'm going to pick degree, make sure that's highlighted. I'm going to exit back out. And then I'm going to type in my 5 times tan 36, just as the same as I had written down on my paper. So there's my answer. Let's round that to say 2 decimal places. So I'd write 3.36 or 3.63. Any questions about how I got this into my calculator or what I did here? Feel pretty good? Okay. Okay. One more thing to get, right? AC is the only thing I have left. What should I use to find AC? So Pythagorean theorem is not incorrect, but it's not our best choice. Why could there be a better choice than the Pythagorean theorem? Still will work, not wrong. What's the downside of using it? Yeah, one of our inputs for the Pythagorean theorem is a rounded answer, which means that we're going to have double rounding. If we use the Pythagorean theorem, we'll have one rounding for the input, 3.63, and then a second layer of rounding on our final answer, which again, for what we're doing, not a problem. It'll be fine. But like if you're trying to land a spaceship on the moon, you might miss. Nino.
I have a question for about BC. Why did you use tan?
So, because when I looked at my picture, I chose to use angle A. BC was opposite angle A, and the side we were given was adjacent to angle A. So I needed a trig function that had opposite and adjacent in it, which is the TOA of SOHCAHTOA. So I used tangent. Is that?
Yeah.
Perfect. Okay. So to answer Gabby, if you use the Pythagorean theorem to do this, you'll get the correct answer. I won't be able to tell the difference, right? But in practice, we should do something different that doesn't require rounded input. It's okay, you'll get the right answer in this context, but there's I'll say a more accurate way you could approach this. Lauren, what's up? Absolutely. So the other way you could approach this, again, Gabby, you're not wrong. I want to be clear on this, like not wrong what you decided to do. Like you'll get the right answer, I won't be able to tell the difference. I mean, I'll see your work, but like rounding to 2 decimal places, I don't think there'll be any problem. So to do this the most accurate way, which requires only 1 layer of rounding, I'm going to do it kind of the same way I did the first one. So I'm going to pick an angle to use. Let's use the 36 again because it was given to us and I'm positive it's no arithmetic error happened in the course of finding that number. And I'm going to use the 5 because that was given to me. That's still adjacent. And I'm looking for AC. That now is the hypotenuse. Which trig function includes adjacent and hypotenuse? Cosine. So I'm going to say that cosine 36 is equal to adjacent over hypotenuse. Notice to write this equation, was there any rounding in any of the numbers I inputted here? No, right? These are all exact value numbers, right? So I'll get the most accurate answer possible. In this class, it won't matter, but like this is just good practice, so we're going to talk about it. To solve this equation for AC, what should I do first? You could, I would not. It's not wrong, but I would not. Multiply by 5? No. Who likes fractions? Nobody does, right? Let's have the first thing we do, get rid of the fraction. What should I multiply both sides by to get rid of the fraction in this problem? AC. Let's do that as our first step. Now again, Gabby, dividing by 5 is not wrong, but it's going to like, now you have to write 1 over AC and make sure you do that, not just write AC, which, you know, like, I think the odds are fair that you write AC and not 1 over AC, and that makes a big ding-dong difference. Lily, what's up? Yes. All right. Here now we have an equation with no fraction left in it. The goal is still to get AC by itself. Is AC by itself? No. Okay, what do we need to do to get AC by itself? What's happening to what operation is happening to the AC? It's being multiplied. How do I undo multiplication? Divide. What should I divide it by? Cosine 36, yes. Oops, already wrote that. So into my calculator, I'm going to write 5 divided by cosine 36. Where did you go? 5 divided by cosine 36. I don't need to check my mode of my calculator because once I've changed it, it stays changed until I either reset my memory or something like that, or I manually change it again. So again, if I round to 2 decimal places, I'm going to get 6.18. And just to illustrate here, if I used the Pythagorean theorem as Gabby suggested. That's the difference between the two answers. To two decimal places, I'm going to have the same number. But notice that one is, they are different numbers, right? And the reason I'm getting a different answer is because of the rounding. So it's fine in this class, like no problem, do the Pythagorean theorem. Just know that like there's a more accurate way of doing it than that. Dan?
Yeah.
Yes. Everybody's okay? Does this all feel familiar? We feel good about doing these kinds of problems, fingers crossed? All right. The other right triangle situation would be if you're given two angles, or I'm sorry, two sides and the 90-degree angle. Actually, I'm going to change this real quick. Sorry. I'm going to write it that way. Sorry about that. All right, so there's three things to find: AC, angle A, and angle C. Which is the easiest one of the three to find? The side. Great. How am I going to do that, Rocco?
3, 4, 5.
Okay, it's a 3, 4, 5 triangle, or I could use Pythagorean theorem in general, right? This special situation, Rocco notices, is like a special kind of right triangle. Or if you didn't notice that, you could use the Pythagorean theorem. So the Pythagorean theorem says leg squared plus leg squared equals the hypotenuse squared. I'm going to do it the general way so that it's, like it would work every single time you run into this situation, rather than the specific shortcut to this one, though it would not be wrong to use a specific shortcut. Because it's notes, I'm going to just, you get it, right?
Yeah.
Okay. So, I have 3 squared plus BC is equal to 5 squared. Oh, I just put it in the wrong spot. Sorry. Thank you, Mary. Everybody's good? Okay, to solve for BC, what should I do next? I got an equation. Okay, so if I subtract 3 squared from both sides, that gives me that, so B squared is 2 squared, right? All you people shaking your heads, yes. No, don't shake your heads, yes. Yes, 100%, yes. You can't subtract numbers like that. Why not? The order of operations is you're breaking, right? You have to do the exponent before you do the subtraction. You can't subtract before the exponent. Great googly moogly. 5 squared is 25, 3 squared is 9, 25 minus 9 is 16. Okay? Then what? So B squared is equal to 16. How do I get, or BC is equal to 16. How do I get BC? Okay, square root both sides. When I do that, what do I get? Close. Plus or minus 4, right? Whenever I square root both sides of an equation, it creates a plus or minus. Now, because we're in a geometric situation, what can I say? It's got to be positive, right? The negative makes no sense at all because it's the side length of a triangle. Lengths aren't negative. So we just have 4. Everybody feel good? All right. Next up, let's find either angle A or C. Does it matter which one I find next? Nope. Let's say we picked angle A because it comes first in the alphabet. Relative to angle A, the two sides that I know are AB, which is the 3. Is that opposite, adjacent, or hypotenuse? Relative to angle A. Adjacent. And the other side I know is the 5. Is that opposite, adjacent, or hypotenuse? Hypotenuse. So which trig function do I need? I need cosine. So I'm going to say cosine of angle A is equal to adjacent over hypotenuse. Still feel good? Okay, how do I get angle A by itself? It's got that cosine wrapped around it. How do I get rid of that cosine? Divide is no. Cosine is not a number, it's an operation. Maybe say like, oh, I'll get rid of the square root sign by dividing by square root symbol. So that's some crazy talk. What cancels out that cosine there? The inverse, yeah, cosine inverse. So we'll do like cosine inverse to both sides. And now it's calculator time. So second, and then the cosine button. That gives me the cosine inverse. 3/5. And I get rounded to 2 decimal places, 5313. Okay. One left. How do I find angle C? You could, but you're doing too much.
Could we just do 180 minus 90?
Yeah, that's the way to go. That's the easy way, right? 180 minus 90 minus 53.13. So that's going to give me 36.87. How do you guys feel on this set of skills right here? Pretty good, right? This should have been largely review over, you know, the course of two separate courses you've done the same set of skills in. We should feel pretty confident doing this. What if it's not a right triangle? Can I use SOHCAHTOA? Have I emphasized it enough? Right? What can't you do with a non-right triangle? SOHCAHTOA. What else can't you do if it's not a right triangle? Have I written it big enough? Okay. Now, in fair warning to everyone in this room, I am going to try to trick you into using these things when you're not supposed to. How am I going to do that? I'm going to do something like this. Oops. Sorry. Do something like this. Does this look like a right triangle? Yes. Is it a right triangle? No. Why not? Doesn't have that little thing in the corner to tell you it's a right triangle. Just because it looks like a right triangle, is it going to be a right triangle? No. Okay? I'm going to warn you right now, I'm going to use that trick on you at least once on a quiz or a test somewhere along the line and try to trick you. Okay? Don't be tricked by me, especially after me telling you that I'm going to try to do this to you. Okay? Don't forget. So the answer becomes then, if I can't do SOHCAHTOA and I can't do the Pythagorean theorem, what the heck do I have left? I have two options. I have what's called the law of sines. Which says that sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Now, critically important, when we talk about angle A, side A, and angle B, side B, and angle C, side C, when I name my triangle, I begin by naming the sides A, B, and C. The side opposite angle A has to be named side A. The side opposite angle B has to be named side B. The side opposite angle C has to be named side C. If your triangle is not named in this fashion, the law of sines does not work. Okay? One of the most common mistakes students will make is they mislabel their sides of their triangle, and then the formulas do not work for them. Okay? The name of the side must match the angle opposite it. Everybody's okay? All right. Our other option is the law of cosines. Oops, forgot the of. That was a false alarm, apparently. So we have a non-right triangle. We have these two options of things we can use, law of sines and law of cosines. The natural next question you should have is, how do I know which one I should use, right? I know I got to use one or the other. How am I going to know? So it's going to depend on what the given information is. So we're going to go back and talk about another idea from geometry to help kind of connect this next idea to these two formulas. So you remember in geometry, you spent a good deal of time doing triangle congruency and similarity proofs, right? Do you remember doing this? Maybe you've blocked it out of your memory because it was so terrible. Do you remember the names of any of those triangle congruency or similarity theorems? Side angle side. Yeah. Does anybody remember another one? Side, side, side was another. Yes. SSA was not one. That was one of them that it's not. Okay. HL is the hypotenuse leg theorem. That is a special case of the SSA. That is a theorem. Okay, there's two more that you guys are missing. Angle works for similarity. I'm talking about congruence, though, Gianna, to answer. I heard you say that. And that is a similarity theorem, but not a congruence theorem. There's two more congruences that we want. Angle side. That's the symbol for congruence. It's the symbol for the congruence. It's the equal sign with the squiggly on top.
I know, but
Theorem.
Oh.
THM. That's okay. You can ask. There's one more. Does anybody remember the last one? Angle side angle. Okay. I'm going to draw some examples of triangles with given information, and you're going to tell me whether it's, a side angle side, a side side side, an SSA, an AAS, or an ASA triangle. Okay? This is super important. Let's start with the easiest one. What type of triangle is this? Side, 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 right? This is the easiest one. It's unmistakable, right? Any questions on that? Okay, which one is this? Or is it side, side angle? Absolutely correct. Mary has it. Yes, this is side angle side. Dan, you were correct. I just wanted to make sure you knew why you were correct. Mary's answer is because the angle was in between the two sides. The two given sides make up the angle. That is side angle side. Contrast that with this, which is side, side angle. Notice that the angle is not made up by the two given sides, right? 5 is part of the angle 40, but 3 is not part of the angle 40. You guys see the difference? Okay. How about this one? Or is it angle side angle or angle side? This is angle side angle. You're correct. Why is it angle side angle and not angle side?
Because the side is
Good, because the side is part of both of the two given angles, yes. This guy would be angle side. Does everybody feel good about seeing the difference between these? Okay. So let's kind of draw a diagram to kind of consolidate this together. Okay, so the first situations we looked at, is it a right triangle? The answer is yes, we're just using SOHCAHTOA. If we have two sides given to us, we're going to use the inverse trig functions to solve. If we have two angles, we just use the regular trig functions to solve. Does everybody feel okay there? So the next situation is if we don't have a right triangle. So if you're given angle, side, angle, or side, angle, those are law of sines situations. If you have side, or side, angle, side, those are law of cosine situations. I'm going to put a little asterisk next to the side angle situation. And I'm going to put the same asterisk next to the side situation. So they have the same note where we have to check to see how many triangles are possible. The SSA situation is the worst case because you can have 0 triangles possible, 1 triangle possible, or 2 different triangles possible. The side situation is not great, but much better. You can either have 0 triangles or 1 triangle. You can't have 2. So I put a little extra note there because there's a little additional check we need to do before we start using our laws of sines or cosines. I'm going to stop here before we've done any examples of like how exactly we run through using these things. So just to recap what we've done today, we reviewed right triangle trigonometry, how to use SOHCAHTOA to solve a right triangle, whether you're given 2 angles and a side or 2 sides and an angle. And we've introduced the formulas for the law of sines and cosines, which you can use in non-right triangle situations. We identified the different sets of starting information you could be given to solve one of these non-right triangles, and then which of the formulas I'd want to use based on the given information. What we have to do now for the next couple of lessons is set out doing examples of these things and practicing using these law of sines and cosines in these specific situations. In particular, worrying about this SSA situation, where there can be lots of different things can happen depending on what the measurements of our givens are. Okay? So we haven't really done much yet, right? We've just kind of set the stage. We're going to get into the nitty-gritty and details next time. At this point, you can do exactly none of the homework that I would have assigned for today. So call yourselves lucky. There's nothing really for you to do at this point, which is fine. It was only 4 problems anyways that I would assign, so that'll be part of next homework sets. We'll just tack it into that, and it's not that big of a deal. Okay? Everybody feel all right? First day was okay, pretty good. It was the first day, that was for sure. Did we start at a common enough point that I didn't leave anybody behind? We remember doing some of this right triangle trig stuff, I hope. Okay. I tried to be really specific and like connect ideas back to previous learning. Try to do that as much as I possibly can to help you organize this stuff in your mind so it's not just like a bunch of papers piled up on a desk, but things are filed neatly into folders and like connected to the things that they're related to. But that's all I got for you guys today. If you are one of the new people to the class, I have a form that I'd like you to complete and bring back. If you guys want to grab this on your way out, it just says that you read the syllabus. Carrie, you do not need to do that because you already did one. Just my 3 new students. And if you look on the My Notre Dame, the syllabus is on My Notre Dame. Emma and Rocco and Sebastian. On the My Notre Dame, if you look at the syllabus, you can see the PDF. Just give that a read through. Thank you, guys.
How did I